Hello students, in this session we will discuss about generalized lists. A generalized list is a finite sequence of n elements. Here, let we take any element. The element is either a single element, which is also treated as atom, or another generalized list. Such a combination is also valid. Now observe this example. Now assume the generalized list L equivalent to, now here they have given a set of elements. Here when we observe the first format, it is a generalized list. Second one is another generalized list where it consists a sub-generalized list and a single atom. And third element is an atom. So here observe, A comma B comma C is a sublist. Another sublist D comma E comma F and a single element as G. So in case of sublist D comma E comma F, it has two elements. One element as a sublist and another element as a single element. Now, such a representation is known as generalized list. Now, to represent this type of format, here the node structure can be designed as it consists four parts: flag, data, down pointer, and link. Here the flag value is either 1 or 0. If flag value is 1, it implies that down pointer exists. If flag value is 0, it implies that link pointer exists. Data part stores element. Down pointer is the address of the node which is down of the current node, whereas link pointer is the address of the node which is attached as the next node of the list. Now observe this example. Assume the generalized list format L equivalent to, now A single element comma sublist as B comma C and another single element D. Now to represent this type of format, here the procedure starts from the header node. So here the element part is A, then here the flag value is 1, that means down pointer exists. Here down pointer points to B and C. Here the next link point is with D. So from this the other nodes are not available, hence those link parts are filled with null pointers. Okay. Then polynomial representation using generalized linked list. So in this format, the node structure is designed with four fields like flag, data, down pointer, and link. Here the flag value is either 0, 1 or 2. If the flag value is 0, it represents variable is present. If flag value is 1, it represents down pointer is present. If flag value is 2, it represents coefficient and exponent both are present. Now observe this example. Assume if the given polynomial equation is p of x comma y comma z. Here this equation is 9x power 5 plus 7x y power 4 plus 10x z. Now this polynomial representation can be shown in terms of a generalized linked list as, now this structure. Okay. The next concept, recursive algorithms for lists. Now when we design a list representation, in some situations it is possible to design recursive algorithms. Now assume initially the node structure is created as node asterisk new node of int data. Open brace. Now node asterisk new node is equivalent to new node. So at this time, when memory is allocated at runtime with the help of new object, now it consists different parts. Now those parts are filled as new underscore node arrow data is filled with data. New underscore node asterisk next is filled with null pointer. Then we return the address of new underscore node. Now we designed recursive algorithms for some operations. Now assume assertion process. Now it shows a recursive procedure to implement assertion process. Here observe, here the base condition. If head value is equivalent to null, then simply return new node of data part. Else, now head arrow next equivalent to, now it's a recursive process, insert end of, now the elements are head arrow next comma data, then return head. Same way, traversing process. So to implement traversing process in recursive way, this one base condition, if head value is equivalent to null, that means elements are not available, simply return. Otherwise, first print head arrow data part and recursively call the same function traverse of head arrow next. Okay. The last one, reference count. Now listen, reference count is a programming technique which is used to store number of references or pointers pointed by an object. So in this mechanism, simply we maintain a count value that represents number of pointers pointed by the object. So here, when we place the extra variable as a count, now this count value is incremented whenever an object is created. Whenever the object comes out of its scope, now the count value becomes 0. So finally, whenever the count value reaches to 0 by decrementing those values, then object will be destroyed. Thank you one and all.